Hello everyone, welcome back to my channel, and today I am continuing my discussion on the topic some common terms in chemical thermodynamics. And in today's video I am going to discuss very important terms, extensive properties and intensive properties, and I am also going to discuss state of a system and state variables. So in my previous videos I told you what is a macroscopic system. A macroscopic system is a system composed of large number of particles, and the properties associated with this system are called as macroscopic properties, and these properties arises due to the group-like behavior or collective behavior or the bulk behavior of the particles. And today I am going to discuss types of macroscopic properties. The macroscopic properties are classified into two categories. Number one, extensive properties and intensive properties. So what are extensive properties? Extensive properties are those properties of the system which depends upon the quantity of matter in the system. And intensive properties are those properties which are independent of the quantity of matter present in the system. In extensive properties, we have mass, volume, energy, heat capacity, and in intensive properties, we have pressure, temperature, density, specific heat, surface tension, viscosity, refractive index. These all are intensive properties. So let us explain that how this mass, volume, energy, they are extensive properties. So let's explain with the help of an example. I have a container containing this much amount of water, okay, and this water will have certain amount of mass, volume and energy. Okay, now what I have done? I have added some more water into it. Okay, now what will happen? After the addition of this water, the mass will increase, volume will increase, and the energy will also increase, because the energy depends upon the height, I have explained earlier. So the potential energy of this water will also increase. This means that mass, volume and energy depend upon the quantity of matter. If the quantity of matter or quantity of water it increases, then mass, volume and energy they all increases. So hence these are the properties which are depending upon the quantity of matter, hence they are extensive. Further, let us discuss heat capacity. Heat capacity is the amount of heat required to raise the temperature of the system through 1 degree Celsius. That is, to raise the temperature of entire system through 1 degree Celsius. So if I have a small amount of water, okay, then less amount of heat will be required to raise its temperature through 1 degree Celsius. And if I have a large amount of water, then more heat will be required to increase its temperature through 1 degree Celsius. This means that heat capacity is increasing with the increase in the quantity of water. So hence this heat capacity is an extensive property. Okay. Now let us discuss intensive properties. So I am starting with temperature. How the temperature is an intensive property. So let us consider that I have water in 3 different containers. I have water in a glass, I have water in a jug, or I have water in a bucket. Now in all these 3 containers, amount of water or the quantity of water is different. What if I have placed all these 3 containers under same conditions, or I have placed these containers in the same room, and if I measure the temperature of water in these 3 containers, I will find that the temperature is same. This means that temperature does not depend upon the quantity of matter. Okay, hence it is an intensive property. Now let us discuss that how density is an intensive property. So density is mass per unit volume. So density is mass per unit volume. So let us define this term in another way. If we have V ml volume, so volume of a liquid is V ml, and mass of that liquid is m grams. Okay, then what is the weight of 1 ml? Then weight of 1 ml is equal to m upon v grams. Okay, so now what is density? Density is the weight of 1 ml of a liquid. Understand? So this is also called as mass per unit volume. Unit volume means to say 1 ml. Suppose again I have water and the volume of water is 20 ml and the weight of that water is equal to 20 grams. Okay, then what is the weight of 1 ml? That is 20 divided by 20 equal to 1 gram. So the density of water is 1 gram per ml. So density of water is 1 gram per ml. Now if I increase the volume of water, suppose I have taken now 40 ml of water. Okay, now the weight will also increase. Then the 40 ml water will have how much? 40 gram weight. Then what will be the density again? That is weight of 1 ml. That is 40 divided by 40. Again 1 gram per ml. This means that density is an intensive property, because as I have increased the quantity of water, the density remains the same. It is again 1 gram per ml. So density is the ratio of two extensive properties. Mass is an extensive property, volume is again an extensive property, what density is an intensive property. Have you understood? So density is remaining the same. So in this way density is an intensive property. Now I will discuss that how this pressure is an intensive property, and it will require some more attention. Okay, I will explain it with the help of ideal gas equation. So let us write. According to ideal gas equation, that is PV is equal to nRT and P is equal to N upon V into RT. Okay, now I will focus on this term. Okay, now I have a gas contained in this container. Okay, and volume of this gas is V liters and number of moles of gas equal to N. So volume is V liters. Okay, then what is this term N upon V? Mean to say that in V liters we have N moles, and in 1 liter N upon V. Okay, so what this N upon V is number of moles present in 1 liter. Number of moles present in 1 liter. So this is called as molar density. This is called as molar density, and it is also called as particle density, because we can easily convert the number of moles into number of particles by multiplying with Avogadro number. For example, in V liters we have N moles, so I will multiply number of moles with what? Avogadro number, it will be converted into what? Number of particles. So here in 1 liter, that is n into n naught. Then what I am going to have? I am going to have number of particles per liter, number of particles per unit volume. So that's why this term n upon V, it is called as molar density as well as particle density. Okay, now if the temperature of this gas, if the temperature of this gas is held constant at T, so the temperature of this gas is constant and it is equal to T, and R is constant, then the pressure of the gas will depend upon this term n upon V, that is molar density, number of moles per liter. Okay, now what I have done, I have increased the amount of gas. Initially I was having n moles of gas in this V liters. Now I have added another n moles into it. Okay, but the volume will increase. I am not keeping the volume constant. Mean to say, if the n moles are occupying V liters, then to add another n moles, I should have V liters more volume. So if I have to add another n moles, then the volume has to be increased by another V liters. Okay. Now how many moles we have? Number of moles we have 2n, double हो गए हैं, and the volume has also doubled. Volume has also doubled and the volume is 2V. Okay, so in 2V volume, now I have what? 2n number of moles, and in 1 liter, how many moles? That is 2n upon 2V, and this is equal to n upon V, that is moles per liter. What does it mean? It means that as I have increased the amount of gas from n to 2n, then the volume has also increased from V to 2V, and the molar density is remaining the same. Previously it was n upon V, and after doubling the amount of the gas, it is again n upon V. This means that this n upon V, that is number of moles per unit volume, it is remaining constant. Okay, then the pressure will remain same. It means that pressure is an intensive property. It does not depend upon the amount of gas or the quantity of matter. Okay, suppose what I do if I half the volume. Okay, initially I was having this volume of the gas, and in this volume I was having n moles in V liters. Okay, now what I do, I divide this container into 2 equal halves, that is like this. Now I have divided this container into 2 equal halves. Now the volume of this container will be equal to V by 2, and here also V by 2, and the number of moles will also be divided equally between these 2 containers. So here I will have again n by 2 number of moles, and here again n by 2 number of moles. So what will be the molar density? That is number of moles per liter. It will be equal to n by 2 divided by V by 2, and it is again equal to n upon V, and this is the case here also. Okay beta, this means that the molar density, that is number of moles per liter, they are remaining constant if I increase the quantity of gas or if I decrease the quantity of gas. So hence, if the number of moles per liter remaining constant, then the pressure will also remain constant. So hence the pressure is an intensive property. It does not depend upon the quantity of matter. So I hope that you might have understood. Next term is specific heat. Specific heat. Specific heat is the amount of heat required to raise the temperature of 1 gram of a substance. 1 gram of a substance through 1 degree Celsius. How it is different from the heat capacity? In heat capacity, the temperature of entire system is increased through 1 degree Celsius. But in heat capacity, the temperature of only 1 gram of a substance is increased through 1 degree Celsius. Suppose again I have 20 gram of water and I want to increase its temperature through 1 degree Celsius. Through 1 degree Celsius, and I require 20 calorie heat. Okay? Understanding? So what is the amount of heat required to raise the temperature of 1 gram of water? 20 divided by 20, that is 1 calorie. Okay? Now I have doubled the amount. For example, now I am having 40 gram of water. Then for the 40 gram of water, how much heat will be required? 40 calorie. And for 1 gram of water, it will be equal to 1 calorie. Understood? So this means that amount of heat required to increase the temperature of 1 gram of water is remaining constant. That is 1 calorie. Doesn't matter I have 20 gram of water or the 40 gram of water. This is how the specific heat is an intensive property, and heat capacity is the extensive property, because here 20 gram was the system. For the 20 gram, entire system was 20 gram. So for 20 gram, 20 calorie heat was required, and here entire system is 40 grams. Then 40 calorie heat is required. So this is heat capacity. So heat capacity depends upon the quantity of matter, and specific heat is independent. Understood? So here I want to tell you one thing, that when a quantity is expressed per ml, that is for 1 ml, or per gram, or per mole, then the quantity becomes intensive. Okay? And this is also the case with surface tension. Surface tension is the force acting on the surface of a liquid per meter or per centimeter. So that's why it is intensive property. And same is the case with the viscosity, because viscosity is the force required to maintain a unit velocity difference between the two layers of a liquid which are separated by the distance of 1 centimeter. So I will discuss these terms of viscosity, surface tension when we will it will come in our syllabus. So this was all about these extensive and intensive properties. Now I am discussing the state of a system. So state of a system is the condition of the system when its macroscopic properties have definite value. For example, if I have an ideal gas or any gas in this container, and this container is fitted with a piston. Okay, and its pressure is P1, its volume is V1, and its temperature is T1. Okay, So these are the macroscopic properties which are defining the state of the system, condition of this system, that this system is having this much pressure, this much volume and this much temperature. Now what I do, I increase the pressure, that I move the piston downward. Now the piston has moved downward. Now what will happen? The pressure of the gas will change, the volume has decreased, and due to the compression, the temperature of the gas will also rise. Now the gas is entirely at a different state. Now let the pressure is P2, volume is V2 and temperature is T2. Okay. So now the state of the gas is changed. The state of the systems is the condition at which its macroscopic properties like pressure, volume, temperature have fixed value, and when these properties are changed, then the state of system is also changed. And to change the system state of the system, it is not necessary that all these three variables has to be changed. If only one variable is changed, then the state of system is also changed. Okay. So what are the state variables now? The state variables are the macroscopic properties, pressure, volume, temperature. So state variables are the macroscopic properties which are defining the state of system. Okay. So these pressure, volume, temperature, these are called as state variables. Because if these variables are varied, the state varied mean to say changed. If these variables are varied, then the state of the system is also varied, changed. Okay, so these are the state variables. What I want to add here, that in order to define the state of a system, it is not necessary to define all the variables. We can have more variables: pressure, volume, temperature, composition, internal energy, enthalpy. They all are state variables. Okay. But in order to define the state of a system, we need not to specify all the variables. For example, if the pressure, volume, temperature and composition, if these four variables are fixed, then the other variables are automatically fixed, because these variables, I will explain it, that this internal energy or the enthalpy, they depend upon these variables, and if these variables are fixed, then they are automatically fixed. Okay, let us understand. Internal energy E is only the function of temperature, and I will explain this in this chapter later on. Internal energy only depends upon temperature. If temperature is fixed, internal energy is fixed. If temperature increases, internal energy increases. If temperature decreases, internal energy decreases. So internal energy depends only upon temperature, and if temperature is fixed, constant, it becomes constant. Okay. And what is enthalpy? Enthalpy is U or E plus PV, where E is the internal energy. And I have explained to you that E is function of temperature. If temperature is fixed, it is fixed. And the two other terms are pressure and volume, product of the pressure and volume. And so if the pressure, volume and temperature, if these three variables are fixed, then enthalpy is automatically fixed. It will have the constant value. That's what I mean, that in order to define the state of a system, we need not to define all the variables. If these four variables, pressure, volume, temperature and composition, if they are fixed, other variables are automatically fixed. Okay. What do we mean by composition? Okay, composition Let us understand with an example. Suppose in this container, now in this container I am having two gases, not a single gas. I have two gases, A and B. Okay, so the A and B are now the constituents of the system, two constituents or the two components of the system. And if I know their percentage, and the percentage of A and B can be easily calculated from the number of moles. For example, suppose if number of moles of A is equal to 2 and number of moles of B is also again equal to 2 number of moles, then what is the percentage composition? Percentage composition is number of moles of A, that is 2, divided by total number of moles, 4 into 100, that is equal to 50%. Okay, so the gas A is present in 50% and B is also 50%. So I will say that in my system I have two constituents and both the components or constituents are having 50% composition. So this is what I mean by the composition, and this composition can be easily calculated from the number of moles. Okay. Now let us consider an ideal gas. Mean to say that now suppose I consider this container, and in this container I have only one gas, only one component. Then what will be the composition of that component? 100%, because only single component is there. The composition is 100%. Now the composition is not a variable. Let me explain. Come to this example. Here I was having two components, A and B, and they were present in 50% composition. 50% A and 50% B was there. Okay, now suppose A and B, they start reacting with one another in this way, that is A and B, they react with each other to give us what? AB. Then what will happen? Then the composition will change and a new gas will be there, AB. In this way, when these two components, they will react, then the composition will be changed, and the composition will be a variable because it is getting changed. But if I have a single gas, okay, not a mixture of gases, a single gas, then there is no chance of changing the composition because the gas is only one and the composition will be 100%. So this means that when we have a single substance or a single gas, then composition is fixed. It is no longer a variable. Then we are left with only three variables, and three variables are now pressure, volume and temperature. Okay, and if we have an ideal gas, then the pressure, volume and temperature, they are also related to each other. They are interdependent according to the ideal gas equation. That is, PV is equal to RT. This is the ideal gas equation for 1 mole. As I said, a number of moles can be converted into compositions. So composition is no longer a variable, and here I have written the ideal gas equation for 1 mole, that PV is equal to RT. The three variables, pressure, volume and temperature, they are interdependent. And if I fix or if I determine two variables, that is pressure and temperature, then volume can be easily calculated. That is, volume is equal to RT upon P. Understood? So what does it mean? It means that here we have two variables, that is temperature and pressure, and volume is automatically fixed. So this temperature and pressure, generally these two variables are chosen, and these variables, temperature and pressure, these are called as independent variables. and this volume is called as what? Dependent variable. Okay, so when we have such type of homogeneous system, then only two variables are sufficient to define its state. Temperature and pressure are sufficient to define its state, because if temperature and pressure is calculated, then volume is automatically calculated or automatically fixed. Okay, so temperature and pressure are independent variables and volume is dependent variable. So I hope that you have understood what are extensive properties, what are intensive properties, and what is the state of the system, and what are the state variables. And in my next video I will discuss thermodynamic equilibrium and various thermodynamic processes. Okay, so please watch my next video also, and if you are liking my videos, then please like, share and subscribe my channel, and also press the bell icon. Thank you very much.